Hi friends, welcome to Social Research Insights. We have been discussing about how to do sensor data analysis in through Arduino microcontroller. In my previous sessions, I've explained how to establish certain simple circuits with the help of some commonly available sensors in the market. We did some experiment by connecting a photosensor, light sensor, or LDR, light dependent resistor, in a very simple circuit connected together with another components like LED and Arduino. So we studied the behavior of light sensor by reading the data from the sensor to the Arduino, and from there throwing the same data into the or getting the data into the Python editor. So this is the code which we discussed earlier in my previous sessions. I'm just going to run this code quickly to test whether the data is streaming from the circuit to the Python editor. So this way, yes, of course, you can see that the data points getting updated in the Python shell. This data actually read by the sensor from the environment. Whenever the light falls on the sensor, that light is converted into the current, and that current is read by the Arduino microcontroller, and from there we are trying to pull the data to the Python shell. As you know that the Python is a wonderful programming language. Once we get the data into the Python, we can do a hell lot of analysis on the data. In my previous tutorials, I've shown you how to compute a couple of statistics, just like arithmetic mean and standard deviation, to understand the nature of the data, as well as through that indirectly we are also trying to understand the nature of the sensor and also the light in the environment where the circuit is present. So in this just before this session, I explained how to understand the normality of this data with by plotting a histogram. Histogram is a visualization adds visualization to the numerical data, where we will try to understand the property of normality. So when we read this data from the environment, and this data points together will represent as a data distribution, and such distributions can be explained with the help of a couple of statistical theoretical distributions. I mean, we have some certain theoretical distributions in statistics, or domain of statistics, where we can probably study the properties of this distribution by understanding by comparing this the actual data with the theoretical distributions. And one such distribution is the normal distribution. So we can study the property of this normality, or the properties of this data distribution, by comparing this with a normal distribution. So in doing so, we are interested to study the normality of this. I mean, when I talk about the normality, we are just interested in studying whether this distribution represents a normal activity in the environment or not. So is there any abnormal activity in the environment? That we can understand by comparing this data distribution with the normal distribution. So we already did that with the help of histogram. So by observing the histogram, we can understand whether this distribution is normally distributed or not. But that is not totally the total way to understand the entire characteristics of this distribution. We also must have some numerical analysis in support of visuals in order to cross-check or confirm our assumptions. In this case, the assumption is going to be the normal distribution. So I'm assuming that this particular data distribution is following the normal distribution. So for that, we have a wonderful statistical test in the domain of statistics, which is, I mean, for some small samples, we do conduct t-test to check whether the location or the scale of this particular data distribution is can be compared with the normal distribution or something like that. So in this case, what I'm going to do, I'll quickly try to explain you the already explained you the normal distribution in my previous tutorial, but I'll just try to if we have a normal distribution in this way, so this normal distribution will be having a mean and as well as standard deviation. So the mean is a location, and standard deviation is spread. So this is standard deviation. So the standard deviation also represents the variance. I mean, can be referred with quite a few names. A few of the names like variance, dispersion, deviation, something like that. So given this information, so it is possible for us to understand the properties of this particular data distribution. This is data distribution. We have data under this curve. This is curve. I'm sorry, my scribble it's not legible. So you have to excuse me for that. So given some information in this way, mean and standard deviation, so we can make use of this information in order to test whether our assumption is true or false. So here I'm going to make the assumption that the assumption in the form of a hypothesis. That is how we do the things in statistics. Okay, if you are not familiar with all these things, you just go back to your school books and try to pick some material related to the statistical diagnosis or statistical tests. In this case, we are just trying to do the t-test. Okay, so that is not a big test in statistics. Any school children can understand. So I'm going to formulate a null hypothesis, and the null hypothesis is going to be like this. My sample information is equal to the information of the population, or the population, the information in the population is normal, or there is no abnormal activity in the population, or the difference between the sample information to that of population information is 0. So in all three circumstances we mean the same thing. That meaning is we are trying to compare the idea is we are trying to compare the sample information with the population information, and we are telling that the sample is a better representative of the population. That's it, nothing else. And the opposite of this idea is going to be the alternative hypothesis, where the difference between the sample statistic and the population parameter is in fact greatly different, or we can also put it in statistic terms that the difference between the sample mean and the population mean is significant. If I say that is significant, it is alternative hypothesis, and if I say that is not significant, that is null hypothesis. So finally we should be in a position to take the decision by either accepting null hypothesis or alternative hypothesis after computing the t statistic. And the expression for the t statistic goes like this. We take the deviation between take the deviation from the sample mean and the population mean, and we standardize that difference or deviation with the help of standard error. And the expression for the standard error is going to be the standard deviation divided by square root of n, which is the sample size. N stands for the sample size. So by performing these calculations, we will be in a position to take our stance either towards null hypothesis or towards alternative hypothesis. And we are also going to do in Python, since it is a programming language, it is very easy for us to do all these calculations. So what we do, we first calculate the t statistic, and after that t statistic, and after that we obtain the p-value for that t statistic. This is an extra step that we need to do, and the p-value is a probability value which interprets, or which stands as a value in support of either I mean, it is a value which will stand either in support of null hypothesis or alternate hypothesis. If the p-value is close to 0, then the data is in support of the alternative hypothesis. If the p-value is close to 1, then the data is in support of the null hypothesis. So that is what exactly we are going to do in this tutorial. So that for that we just have to write the code in as I said, we have a wonderful environment in Python to do all this code. So I'm going to just define a function, and that function is going to be my t-test. We'll try to supply an input which is data. I just simply write it as dead, and I keep all these names as short as possible so that we'll save the time. And first we need to compute the sample mean. What is this sample? Sample of the data that which we are getting from the sensor. Sensor is throwing the data to the Python. We'll get a sample of the sensor data for 15 iterations, so that we'll be our sample size is going to be 15, which means n is equal to 15. And from that sample data we are going to compute the sample mean. And anyway, population mean is going to be 0, because we are going to check that though we have some significant effect in our sample, but in fact the difference between the population mean the difference between the population mean and the sample mean, given some certain the variance in the data, is in fact insignificant. So that is what is going to be our exercise for this tutorial. First, let me compute the mean. These things I explained in my earlier tutorials. To compute the mean, I first have to go for the numerator is going to be the sum of that, and the denominator is going to be the number of data points in the data. And we have a wonderful function called length, LAN, that which will return the count of that data. And the mean is going to be the ratio of num to that of den. So I'm telling the Python that you just compute this ratio and keep that value in an object called m. So what is this m? This is actually the mean. And after that we need standard deviation, and from the standard deviation we have to compute first let us compute the standard deviation. To compute the standard deviation we need to compute two more measures. That is, number one, sum of squared deviation. And in my previous tutorial I've told you in detail as how to compute the sum of squared deviation. For that we need a for loop for I in dat. The sum of squared deviation is going to be sum of, take the deviation for that I minus m, mean. So we are subtracting each and every element in the dat from the mean, and then we take the square for I in dat. So I'll just put it here. Yes, I think now it should be. So we should have that highlighted gray color stripe when we finish the right side parenthesis in Python. So now I think it is we follow the symmetry of Python. Now we'll come out of the for loop and go for the var. Var is going to be the average of SSD by length of dat, and standard deviation is going to be the square root of var to the power of 0.5. And now we have the standard deviation. From standard deviation let us go for the standard error, SD by square root of n, length of dat to the power of 0.5. So that's going to be SC. Now it is very easy for us to compute the t statistic. Our t statistic is going to be our mean minus 0, which is because the population mean is 0. We assume that the population is normally the data in the population is normally distributed, and if we make that assumption, we are indirectly mean to say that the location is 0 and the standard deviation is 1, and which is divided by the standard error. And now in SciPy we have a wonderful module called stats, in which we have a procedure to compute the p-value. So my p-val is going to be I attach the module as in the form of SP. This is another beautiful mechanism available in Python to call the packages and the modules in those packages. So SP take T, again another module in the sub-module in the module SP, and we have cumulative distribution function, which is highlighted in this case. Compute the p-value. I'm just telling for T statistics, and degrees of freedom is good. Sorry, we didn't compute the degrees of freedom here. Degrees of freedom is going to be length of that minus 1. So that is the degrees of freedom. So take the degrees of freedom. For these degrees of freedom, compute the p-value for this statistic and return that p-value to me whenever I call this function. Okay. So now we have the data streaming, and we are going to use this function print my t-test over df. That's all. So let's say all the best. Go to the run and run the module. Come on. Yes, we are able to read the data till now. The code is going appropriately. There's no problem in running the code, but we must be able to print rest of the information and come out of yes, exactly. So congratulations. We have to say congratulations to ourselves, because we have run the code successfully and our function is working perfectly. So if you see the output, we've told the Python to print the each data element, which is streaming from the serial monitor, and this is actually the sensor data. Different instances of the sensor data. And we also told the Python to take all those data points for 15 iterations and print the data frame finally. We are coming out of the loop and printing the data frame for all those iterations. You can see that in the first iteration 89.63 here. You can compare these values and see that we made a data frame out of this streaming data, and finally we computed the p-value, and the p-value, we are printing the p-value with the help of a function, print function in Python. So compute the p-value by using this function, finally print the p-value. This is how we are going to obtain the p-value with the help of this function. We can also change the couple of other, the way we can also get the other information. We have wonderful information in this. We have other couple of statistics apart from the p-value available from this function. Namely t statistic, p-value, and also if you want, you can also go for the standard deviation, variance, and everything. But I think these two things are sufficient right now for us to. So I tell the function to return me two values. The one is t and the other is p-value. And if you are interested, you can also get the other information. So here I'll come to the end of my code, and I write some statement. T value and p value of the data A are comma, then do this. Okay, p-value of the data, or you can also write the statistics of the. So let's go run the module and see what's going to happen. So we are getting the data. The data is streaming from the serial monitor, and the loop will stop after 15 iterations, and it will print the data, and finally, see here you can see that the t value and the p value of the data are for the data. So 7.25 is the t value and 0.99. We can also stop this. I'll just don't print data, you just make it silently, and also don't print the data frame, do everything silently, and finally just give me the t value and p value. T value and p values for sensor data, so save. So now Python is silent. I think it must be reading the data. So this time it will just gives us the output and quits. So let's wait and see. This time we get the same value, t value and p value. Yes, exactly. T value and p values for sensor data. This time the t value is 8 and the p value is 0.9. Okay, fine. So we got our data, the statistics exactly as intended through our code. And how are we going to decide now? So our p value is, the probability value is 0.99, which is very close to 1, as I said. If the p value is 1, then we have the data supports the alternate the null hypothesis. So in this case we are not able to show evidence in support of alternative hypothesis, and and we are going to conclude that the sample information is identical with the population, the information in the population. So the difference between the sample mean to that of population mean is not significant, which is 0. Okay, so though we observe some abnormal activity in the sample, but the population, this sample had come from a population which is characterized by the normality. So so it is possible for us to, so whatever the deviation that we observe through the sample is only as a matter of chance. In reality, that deviation can be observed in the population. So we can still assume that the data in the population, there's nothing abnormal activity in the population, though we observe some abnormal activity in the sample. So this way we can make inferences by using the statistics on sensor data. Okay, if you like my video, please press like, subscribe to my channel, stay tuned for the new content. Thank you.